Is an AI-powered robot the key to a revolution in quantum manufacturing? Scientists have developed an AI-enabled robotic probe to fabricate carbon-based quantum materials at the atomic scale. The breakthrough highlights the potential for using artificial intelligence at the sub-angstrom scale for enhanced control over atomic manufacturing, the National University of Singapore said in a statement. The method combines scanning probe microscopy techniques and deep neural networks. Dubbed the Chemist-Intuited Atomic Robotic Probe, or CARP, the technique is a potential game-changer for developing next-generation spintronic devices and quantum information technologies. The team tested the CARP concept on a complex reaction. The robot understood and executed on tasks like a scientist, changing the shape and properties of molecules. They also leveraged a smart learning approach to extract new insights from the reaction that might be overlooked by humans. Associate Professor Lu Jiong, who led the project, said, "Our main goal is to work at the atomic level to create, study, and control these quantum materials. We are striving to revolutionize the production of these materials on surfaces to enable more control over their outcomes, right down to the level of individual atoms and bonds." Advanced quantum materials can be used to drive quantum computing, enhancing electronic devices and communication, and potentially unlocking new discoveries in pharmaceuticals and renewable energy. The National University of Singapore is known for its leadership in quantum research. Professor Lu said his team plans to refine the CARP system to allow for chemical reactions on surfaces with greater efficiency and scale. They aim to move from traditional lab-based methods to developing materials directly on chip, which Lu said could accelerate research on quantum materials and usher in a new chapter in precise atomic manufacturing for real-world applications.